Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Hazim bin Alida Fairuz. My metric number is AN190026. My supervisor is Dr. Nur Ain binti Sahari. So today I will present about my final year project, which is development of smart fish stabilizer for aquarium fish tanks application. So next, for chapter 1, introduction. A smart fish stabilizer benefits to all fish lovers around the world to give fish a better environment and a good quality of water all the time. The pH level in a tropical fish tank should be between 6.8 and 7.2. The smart pH stabilizer is built on the Arduino Uno, which combines electronic components to function the system to on and off, control the sensor and water change itself. This system ensuring it has balanced appropriate pH levels for the fish. It is possible that the fish will die if the water gets excessively alkaline or acidic. This smart pH stabilizer is eco-friendly to all users, thus it lessens the burden to take care of the fish to all human beings. The result is the smart pH stabilizer always makes sure the water is in the suitable and safe pH range for the fish. So next is problem statement. So majority people still use the same method by handwork water changing. Maintaining an aquarium's water quality level in the appropriate range promotes fish development and decreases the occurrence of fish illness. Manual monitoring and replenishment of water is time intensive, and because water quality fluctuates frequently, it will not provide an accurate result. As a result, a smart pH stabilizer is being developed to address this issue. This system comprises of a pH sensor that detects the pH level of the water and a water pump that removes water from the aquarium if the pH level is not within an acceptable range. The pump will cease functioning after a certain number of minutes, and another water pump from the water supply will replace it to replenish the aquarium with water until it reaches the desired pH level. Because water changes, this method can always provide good water quality for the fish. This project requires a very well-designed pipe system to allow the pump to operate at a high pressure, and highly pure and clean water was required for the water changes as well as chlorine-free water. So next is our objectives. First of all, to design a smart pH stabilizer for the aquarium application, which can monitor the water pH level as well as automatic water changing. Second is to evaluate the detection pH level based on number and location of pH sensor. Lastly, to investigate the amount of water needed to achieve the stability of pH value. Next is our project scope. So, this project focuses on researching and manufacturing a smart pH stabilizer to maintain the greatest water quality in a fish tank by reducing ammonia levels. As a result, the following is the project scope. First of all, specifically for aquatic fish in large aquariums, medium fiber tank glass and small pond, estimated for 100 to 500 gallon of water. A microcontroller will be used as the controller of the entire system to allow the system water changing to be done automatically. pH needed for the fish between 6.8 to 7.2 for the best quality of water needed. 2 fish tank use and 2 containers for water change purposes. Next is for our literature review. Factor that causes water turbidity involving pH levels. So, number 1 is carbon dioxide and other chemicals such as nitrates may be absorbed by aquatic plants, elevating pH levels. Excess algae and slime should be checked on glass decorations and rocks. Second, tap water contains alkaline compounds and metals, as well as the contaminants. As a result, most specialists advise against using untreated tap water in aquariums. Third is overfeeding can raise the pH level of the tank, and the fish pellet can also elevate the turbidity. And lastly, pH levels can be raised by the presence of fish excrement. To eliminate fish waste as effectively as possible, a filtration system must be installed within the aquarium. So next is our project flowchart. We can see this diagram of our flowchart. The process is activated when the pH of the water changes. When the pH sensor detects contaminated water in the aquarium, the water pump 1 is activated. A timer will be set to X minutes to stop the suction. Water will remain in the aquarium, but because there will be fish in the tank, not all of it will be pushed out. When the timer goes off, water pump 2 kicks in and keeps filling the aquarium with fresh treated water until the pH reaches 6.8 to 7.2. The procedure will be repeated if the pH level value stays outside the range, which is why it is called a smart pH stabilizer. So this is our 3D design using AutoCAD. This 3D AutoCAD model of a smart pH stabilizer contains aquarium fish tanks, an aquarium stand, an Arduino microcontroller box, and electronic components like pH sensor, water pumps, and so on. This size was chosen since it is a low-cost design that can be utilized both indoors and outside. It's the size of a standard aquarium, so it's neither too big nor too little. The sewage and purified water tanks beneath the aquarium fish tanks are split into two parts. 2 water pumps will be placed in the aquarium fish tanks and the treated water supply tank. The objective of the aquarium water pump, which is located at the bottom of the aquarium, is to suck all the fish droppings and excess fish food. So next is for our result and discussion. For the expected result, as a result of our study, the fish tank will clean itself when the pH level fluctuates. The water changing operation will take roughly X minutes according to the present sensor. This can lower the amount of people needed to clean and change the water in order to maintain the quality of the water. As a result, the water supply will be mixed with anti-chlorine and the pH will remain steady, ensuring that the fish tank is free of bacteria and chlorine. 2 water tanks will be included, one for clean water and the other for sewage from the fish tank. Many parts of the system may be changed, including the pH level sensor. As a result, the technology is scalable and supportive. Using this sensor, the system will constantly monitor the pH level in the fish tank and keep it in excellent working order. The pH level in the aquarium will be shown and monitored on an LCD. The smart pH stabilizer system will be completely functional thanks to the code attached to the Arduino Uno, which can operate the sensor. The integration of sensor in the system allows the system to adapt to the user's reaction, making it more efficient and user-friendly. So for our conclusion, finally, a smart pH stabilizer generate clean water for aquatic life by automatically adjusting the pH level in aquarium tank, so that the fish do not become stressed as a result of the water's pH levels being too high or too low. Due to poor water quality produced by fish droppings or feces and abundant food, the pH value is unstable. The water quality deteriorates when fish feces begin to produce germs that can infect the fish. That is why maintaining a constant pH value necessitates water changes. Without any operator involvement, this pH stabilizer would operate when the pH value hits the maximum or lowest level by water change. There will be two water pumps, one to drain the dirty water from the well and the other to fill the well with pure water. Two water pumps will be installed, one to drain the aquarium's dirty water and the other to give the anti-chlorine water. This project is always being upgraded to ensure that aquatic life has access to high quality water. So this is my Gantt chart. Next is the reference. So that's all from me. Thank you.